Thank you, calumliggett, for this great question. I like the title. It says, please help. So it says you must use the sine rule. And then I guess this is copied and pasted, so this is like part A of a question. A radio station tower was built in two sections. From a point 100 meters from the base of the tower, the angle of elevation of the top of the first section is 30 degrees, and the angle of elevation of the top of the second section is 45 degrees. Find the height of the top section of the tower. Okay, so this question's a little confusing how it's worded, but I'm going to tell you what my interpretation of it is, specifically the last sentences. Find the height of the top section of the tower. I think it means like just that, the height of the top section, but it could mean the length of the top section depending on how you are interpreting what they're saying here. So I drew this little clunky picture of the thing. Okay, so this is what I'm calling the top of the second section here, and that's what we're ultimately looking for. And then these are our angles of elevation. So angle of elevation is from the observer up, and then angle of declination would be these guys down to the observer. So that's just little gee whiz information. So let's work with this triangle first. I'm going to call this angle alpha, and I'm going to call this angle beta. Okay, and we need to make use of the law of sines here, which I think they're calling the sine rule. We're also told that the distance from the observer to the base of the tower, this length here, is 100 meters. I think meters is what it was given in, 100 meters. Okay, so we need to find this length here. So first let's start off with the first section, and then we can calculate the second section after, even though we might not need it. We're told that alpha equals 30 degrees. Alpha equals 30 degrees. And since this is a tower, we can take this to be perpendicular. So that means that beta must be 60 degrees. Okay. And the reason why I think that they may have meant the length of the second section is because otherwise you could just do this problem with the angle of elevation from the second section right here, this being 45 degrees, and you would never need to do anything with the first triangle, this 30, 60, 90 triangle. You wouldn't need to know anything about the first section to calculate the height of the top of the second section. So I think maybe what they actually want is the length of the second section. Okay, so let's calculate this segment here. Oops. Oh my goodness. That segment is what we're going to calculate. And so since alpha is 30, and we can use the law of sines here, the law of sines says that the sine of alpha over, let's call this side alpha, is equal to the sine of beta over, and we'll call this side. Actually, let's not call this alpha, let's call it A. A. And the sine of beta over B. Okay. So the sine of alpha over A is equal to the sine of beta over B. And this would be true for the ratio of the sine of an angle to its opposite side is equal for all side angle pairs inside that triangle. So sine of alpha over A is equal to sine of beta over B, and then the sine of this 90 over the hypotenuse. So all three of those ratios are equal. We know alpha, beta, and B. All three of those things are known, which means we can solve for A. So let's plug all of those in. Or actually, let's solve real quick. I'm going to multiply both sides by A, and then I'm going to multiply by the inverse, or the reciprocal of this sine of B over B. And I'll get A is equal to, and we'll call it B sine alpha over sine beta. Okay, and then we can just plug everything directly in here. I said b is equal to 100 meters, and then we've got the sine of alpha, which was given to us as 30 degrees, and we know that this is this middle one here is 90, so this has to be 60, since the interior angles all sum up to 180. Okay, and this is calculator magic. Actually, we can probably calculate this. So this is the sine is going to of 30 is going to be 1/2 divided by the sine of 60, which is √3 over 2. So we're going to get √3 over 3, right? And then that'll be times 100. 100 sine 30, which on mode here, degrees, sine 60. Okay, so 57.735. All right. And this is an approximate value. So there are more after that. And I'll use this expression to calculate the next one. Okay, so let's clear all this stuff up down here. So we said A is equal to B sine alpha over sine beta, which equals approximately 57.735. Okay. Now, then again, we're given this big angle here as 45. And let's call the big angle theta. And then I will call this guy, which is its complement, I'll call this phi. And obviously they share the same 90 degrees here. And they also share the 100 meters as their leg. So the same relationship, right? We have the sine of theta over, and let's call this whole side, I'll give this one a, what is it over theta? So I'll give it a t plus a, okay? That's going to be t plus a. T plus a, but we already know a. And it is going to be equal to the sine of phi over b, which we also know. So we need to solve for t. That's the only thing we don't know. We know theta is 45, and thus phi is also 45. So we'll cross multiply here and then divide by sine theta, and we'll be left with t plus a equals b, and then we'll subtract a, and we get t equals b minus a. And really, you know, we can just eyeball this and know what this full length is. If this is 45, this is 45, and the base, the legs have to be the same. So 100 meters here and 100 meters here. So then if b is 100 meters, then t plus a has to be 100 meters, and we can just solve for t right from that. So it says you have to use the law of sines, and I guess you have to use it to find a here. But let's just do 100 minus what we got from our last portion of the problem where we found a, and we'll get, so t is approximately 42.265. Okay, and I rounded that to here. So you can use that as your answer, I guess. This gives you this portion, right? The height is actually just 100 meters. And I don't really, I guess you could say you need the law of sines for that, but you don't need this bottom triangle if that's the case. So if you want the actual height of the where the top of the second tower, the second section of the tower is, then it's just 100, and you don't need that whole first portion. You just use the 45 and the 100 and the sine of theta over this height is equal to the sine phi over 100 meters, solve for the leg, and you're going to get 100 meters. So either t equals 42.265 is your answer, or it's 100 meters. And I'm not sure what they really want. From the wording, if I'm being literal, they want this. Who knows?